Algorithms have been around for as long as anyone can remember. They were and still are used for all types of things, but before I go any further, let me explain to you what an algorithm is. An algorithm is just a set of instructions that can be followed to do something. And well, they can be found anywhere, from cooking recipes to teaching computers how to sort numbers. A simple algorithm you could make right now would be to list the steps that you take to travel from your house to school, or list the steps that you take to wash your hands with soap. They may be simple, but they're algorithms. Now, taking a look at algorithms and programming, they're a bit more abstract, but they represent a specific approach to a specific problem. And what you do as a programmer is implement those algorithms to solve the problems. To help you guys understand what an algorithm is, I've created a situation that occurs pretty often. So let's say your parents are driving you somewhere they've never been before and they need directions. So they use Google Maps or whatever app they have to get the directions, and the phone tells them to go straight for 2 miles, turn right at X Drive, and finally tells them to look for their destination on their left. So this is essentially an algorithm. Your parents have been given a set of instructions that they're going to follow to achieve a certain task. So now moving on to a simple example of a Java algorithm, the bubble sort, I'll just be going over the logic that makes up the algorithm. Don't get caught up in the name or Java code that goes along with the logic that I go over. Just focus on the logic. So let's say you have 5 numbers, 3, 1, 2, 5, and 4, and you want to order them so that the smallest number is first and the biggest number is last. So what we have to do as a programmer is teach the computer how to sort these numbers in order. What we'll basically do is go over all of the numbers and look at each number and the number to its right. If the number you're at is bigger than the number to its right, just swap them. That's about it. Now if you keep doing this and you go through all the numbers several times, you will eventually put each and every number in order. So let's sort the numbers we have on the screen. We'll start at the first number, which is 3, and we'll look at 3 and the number to its right, which is 1. In this case, 3 is bigger than 1, so we swap them. Now moving on to the second number, which is 3 again, because we just swapped 3 and 1, we look at 3 and the number to its right, which is 2. 3 is bigger than 2, so we swap them again. Now we move on to the third number, which is 3. Look at 3 and the number to its right, which is 5. 3 is smaller than 5, so you don't change anything. We move on to the fourth number, which is 5, and we look at 5 and the number to its right, which is 4. 5 is bigger than 4, so we swap 5 and 4. Now, if you take a look, the numbers are all in order. So what we basically did was go over all the logic that makes up the bubble sort. And the bubble sort is a fully fledged algorithm that's really commonly used by programmers all around the world. Now, let's take our minds off algorithms and delve into flowcharts and how they can help us map out algorithms. A flowchart is a diagram that you can use to represent an algorithm, and it's very commonly used because visualizing or being able to see and plan out complex algorithms makes it much easier for programmers to solve problems. It's sort of like an outline for writing your English essay. There are 4 different shapes that are used to make a flowchart. An oval is used to represent the start and stop of an algorithm. A parallelogram is used to represent an input or output. A rectangle is used to represent a process or task being completed by the computer. And a diamond is used to represent a decision being made by the computer. Using these 4 shapes, you can take an algorithm and break it down into individual steps that can simplify the process of solving problems. Let's revisit the bubble sort example that I went over a few minutes ago. I'm going to construct a flowchart that captures the basic logic that I explained before, but I recommend that you pause the video and create the flowchart yourself. So I have an oval to begin with that represents the start of the algorithm, and I have an arrow going from the oval to a diamond, which represents a decision that has to be made by the computer. Arrows in flowcharts tell us the direction of the flow. In other words, they tell us the order in which each step of an algorithm is carried out. I added a diamond because the computer should check if the numbers are in order or not before doing anything else. It would be unnecessary for the computer to sort an already sorted list of numbers, so it's just an extra step that I added to avoid redundancy. If the numbers are already in order, the algorithm should end, because there's nothing else to do. If the numbers aren't in order, the computer has to sort the numbers through the process I went over before. And that's basically it. This is a simple flowchart that just maps out each step of the algorithm, and this allows a programmer to go through each step and program the code that the steps represent.